All right, so this whole vector thing is very, very important. So I wanted to make a video. This way you guys can review it at your leisure. You need to go back to something. And I'll be doing it for the second version of this worksheet that you are going to do or may have done depending on which class you're in. So when we talk about free body diagram, we have to understand that there's always going to be gravity, and that gravity is always pulling down. If it's two surfaces in contact, then there has to be a normal force, and there's very likely going to be a frictional force. Now, normal is always perpendicular to the surface, so it's supporting. It's got to be going up, like I put here. Friction is always opposing motion and parallel to the surface, so if it's moving to the right, it's got to be to the left. And of course, we see that there's an applied force. And if we didn't see that, well, we're told right here there's an applied force, there's a normal force, there's a frictional force, and a gravity force. So either way, we should come up with those ideas. Now, I recommend, don't say it's mandatory, but I do recommend that you make a little table here of your components. Okay, so we have X and Y. All right, X has to do with the X-axis, Y has to do with the Y-axis. And remember, you've done this in math before. Positive X is to the right, negative X is left. Positive Y is up, negative Y is down. So when I fill out the table, I'm putting things according to where they are. Now, you don't have to put in these zeros, so if you wanted to leave the, these blank, that's fine. But I'll explain those numbers in a minute. So we were told that the applied force is 500 newtons. I see that my applied force is to the right, which means the positive x-axis. So I'm putting 500 on the x side, and I'm leaving it as a positive number. We're told the normal force is 800 newtons. Well, my diagram says the normal force is up or on the positive y-axis, so I put it in the y side on the positives. Then we have the frictional force is 325. Well, friction was to the left. That's the negative x-axis. So I put it on the x side and I put it in as negative 325. And then we have gravity, which we said is down or in the negative y direction. So it's a negative y. When I add up at this point, these we're going to cancel out. 800 plus negative 800 is 0. 500 plus negative 325 is 175. So there is my net force. 175 newtons, and since it's positive, and then the x, positive x is east or right. I don't care if you say right or east, that's fine. All right, so that's the basic idea. Now let's just complicate it a hair by taking that applied force and putting it at an angle. Okay, so when the applied force is at an angle, okay, we have the same free body diagram as in the previous problem for the most part, except instead of this being on the x, it's up and to the right. Okay, so that means it has two components to it. We have to break it down into a triangle and talk about how much of it is to the right and how much of it is up. Okay, so we know the hypotenuse is 500. We know the angle is 30 degrees. That was given. So cosine is adjacent over hypotenuse. So the cosine of 30 would be x over 500. So that means 500 times the cosine of 30 is x, and that means x would be 433 newtons. And let me get my picture out of the way and talk about the y. So now y is on the opposite side, so opposite over hypotenuse is sine. So I said sine of 30 is y over 500. 500 times the sine of 30 is y. Y would be 250 newtons. So I know that my applied force now is going to the right, 433 newtons, up 250 newtons. So in my table, I put it as positive x and positive y. To the right, 433, to the and up 250. And then the other forces go in just like before. So the normal force is going upwards. That's positive y. Where is, wait, do I have these in the wrong order? Oh, there's a typo here. That's why. The normal force was 800 on your sheet, and this was 1050. Okay. Anyway, so the normal force, positive y, 800 newtons. Okay. The frictional force is 300, but again, it's to the left. It's a negative x. And gravity is down, that's negative y, 1050. So again, this side adds up to be 0. We're going to see that happen a lot. And on this side, 433 and negative 300 gives me 133. Again, I got a positive answer, so my net force is 133 newtons to the east or right. Okay. All right. Number 3. Okay. We're looking at this little knot right here where it says 0.0, and we're drawing the free body diagram. So we're told that tension 2 is pulling it to the left. If you want to call it T2 still, that's fine. Usually we say FT, the tension force. Okay, FT1 is going along this angle here, and FT3 is going down. Okay, so the arrows were actually on these pictures if we kind of zoom in and look. Okay, so it was really, the free body diagram was practically given to you. All right, so we know that tension 1 is 800. Excuse me. But tension 1 is at an angle. It's going up and to the right, and we have this 60-degree angle up here. Now, I could say this is a 30-degree angle here. I usually just work with what's given. So I drew my triangle here and said, all right, we have my x, I have my y. Cosine of 60 equals x over 800. 800 cosine of 60 equals x. X is 400 newtons. Then I find the y component. That's the opposite side, so I use sine again. Sine of 60 is y over 800. 800 times the sine of 60 is y. Y equals 693 newtons. I don't know why I didn't round off here. I usually do. Okay. So now I have my forces. Okay. I have this broken down in components, and this is already on the y-axis. This is already on the x-axis, so I fill out my table. Tension 1, we just said, had an x component, which was 400 newtons to the right, 692.8 newtons down. Tension 2 was going to the left at 400 newtons, so it's negative 400 newtons. Tension 3 is going down, that's negative y, negative 692.8. So again, this adds up to 0. But this also adds up to 0. So our net force is 0. This object is at rest. All right. And lastly, we have 2 applied forces in this situation. A block is being pulled down at an angle of 45 degrees and pulled upwards at an angle of 30 degrees across a rough floor. All right. So one is pushing down and to the right, the other is pulling up and to the right. Now, if you wanted to put this one on this side in your diagram because it's going down and right, that's fine. All that matters is that you have the arrow showing direction. But if if I literally wanted to just take this and put it here, that's fine. No problem with that, okay? That's okay for a free body diagram. So either way, because the arrow is where it is, you'd be okay. All right, so I have to break down FA1 into components. I have to break down FA2 into components. All right, so we know that the downward one, FA1, is 424.3 newtons, and it's at a 45-degree angle, so I draw my x and my y. Now in this case, because it's 45 degrees, I know that both of these answers are going to be the same. I showed the work anyway, but it's an isosceles triangle, so x and y have to be equal. So x would be 424.3 times the cosine of 45, which is 300 newtons, which means y is 300. Now, technically, I got to keep in mind that I'm pushing down and to the right. So this is really going to be a negative y, but this is going to be a positive x. It's going down and right. Let's go to the other force. So the other force is going up and right at a 30-degree angle. So I draw it up and right at a 30-degree angle. Put in my x and y. Again, if you set it up the same way every time, then cosine is going to usually mean x. So cosine of 30 is x over 900. 900 times the cosine of 30 is x. X is around 779 newtons. Sine of 30 equals y over 900. Y equals 900 sine of 30. Y is 450 newtons. All right, so now I have all my forces. I'm going to put them into my table. FA1 we just said was going right but down. So again, negative 300 there. FA2 is going right and up. So both positives. The normal force is up. Frictional force is to the left. That's negative. And gravity is down, which is negative y, so we put it there. So again, the y components all added up to be 0, and the x components add up to be 579.4. 579 is fine, newtons east or right. All right, so, hopefully you can go back over this. If it doesn't explain it, please ask questions. I hope it helped. All right, talk to you soon. Bye.